In this video, we present Frappé, an ultra-lightweight mobile UI framework for rapid API-based prototyping and environmental deployment. These days, there is a mobile app for everything. This is also reflected in the exponentially growing number of apps available on the app markets. Consider a smart light. In order to use it, we will first need to download an app for it. And typically, QR codes are used as an inexpensive means for redirecting users to these app markets. As we progress towards an increasingly digital world, we can observe similar trends of many other user experiences being augmented inside such mobile applications. However, this also introduces a significant dependence on having a stable internet connection to obtain these apps, which can pose a serious usability issue in regions with limited network connectivity. Native apps usually weigh well over 10 megabytes, sometimes going well into hundreds of megabytes. Instant app frameworks such as Apple's App Clips and Google's Play Instant are typically capped at the size limits of 5 to 10 megabytes. Web apps have lesser network bandwidth requirements, typically using 100 kilobytes to a few megabytes to load. A large fraction of these network bandwidths are used to load libraries and frameworks of the app. However, the user interface metadata in itself can be made very lightweight, and an uncompressed request header, which can be used to trigger app functionality, usually requires less than a kilobyte to send. We leverage this to create our mobile application framework, Frappé, which can augment the interactive capabilities of QR codes to not just redirect users to app markets, but instead serve the entire app's user interface without the need for any network connection. Using Frappé, app developers can create ultra-lightweight functional apps which can be loaded on a mobile device without any network connection and requires a minuscule amount of bandwidth for operation, making it suitable for ubiquitous use even in areas with very limited network connectivity. Frappé achieves this by encoding the user interface metadata inside a QR code and offloading all functionalities to API calls. An end user can load Frappé apps by simply scanning the QR code, and the user interface is reconstructed ad hoc on the user's mobile device. We also designed an app builder tool in Frappé to allow developers to easily create Frappé apps. We will now demonstrate the workflow of our system. For this example, we will be creating, deploying, and testing a smart light controller app using our Frappé framework. An app developer can use Frappé to design the user interface of their app using simple drag and drop gestures. Once the user interface is designed, the app developer can link the button-on-click events to change the activity or perform API calls. Frappé also allows developers to attach data from other UI elements to be sent during the API call. After this, the developer can fill up the app metadata and then test the app directly within Frappé. Once the developer is satisfied with the results, they can deploy the created app. A key highlight of Frappé is its ability to facilitate extremely low-cost app deployment. To deploy a Frappé app, the developer can simply print the entire application as a QR code and paste it in target locations. Any end user who needs to use the app can load it on their mobile devices by simply scanning the QR code. The user interface reconstruction is instant, requires no network connectivity to load, and consumes an insignificant amount of memory. Our framework can support various application scenarios such as data collection, physical object interfaces, and virtual controls. We performed a technical evaluation of our framework where we compared the performance of 5 sample Frappé apps against identical web and native applications. Since only the UI metadata of an app is stored in our framework, it results in significantly less app size, which can be stored within a QR code. Web and native apps, on the other hand, weigh significantly higher because of various framework overheads. Apps created using Frappé consume significantly less network resources as compared to web and native apps when comparing first-time or ephemeral use cases, since Frappé apps require network connection only for triggering app functionality. Lastly, apps created using Frappé demonstrate comparable load times to web apps accessed using high-speed internet and are significantly faster when compared to the load times of native apps. We also conducted a user evaluation to validate our system's ease of use, learnability, and utility value. We recruited 16 participants of varying app design expertise. The participants were first given a tutorial of building apps using our framework, and then they were given 3 app building tasks in order of increasing complexity. All the participants were able to successfully complete the tasks and reported high learnability and ease of use of the system. Participants also reported a high utility value of our system and suggested several use cases for our framework. Our system demonstrated several benefits through the technical and user evaluations. However, our system does come with some limitations. There is an inherent trade-off between customizability and app size. Since one of the primary goals of our framework is to create ultra-lightweight applications, it is not ideal for rich user interfaces, but rather for easy-to-access interfaces which can support primitive functionalities at a low cost. In our current implementation, while the user is able to obtain the entire user interface directly through a QR code without the need for any network connection, using the application still requires a minuscule amount of internet bandwidth because the user interface is connected to the functionality through RESTful APIs. However, our system can be made completely internet-free if other communication mediums such as BLE or NFC are used to make the connection. Lastly, we acknowledge the security challenges that our framework presents. While visual markers such as QR codes are inexpensive and convenient, they are inherently prone to security vulnerabilities. In its current state of development, we do not recommend using Frappé apps to perform transactions of sensitive data. Future work may explore the use of digital signatures, encryption techniques, or switch to a more secure transmission medium to bolster users' trust in Frappé apps. QR codes are ubiquitous, inexpensive, and have a low barrier of access. And yet their modern-day use cases are very one-dimensional. In a future where everything has a digital presence, we envision our work as building blocks for augmenting interactive capabilities to such lightweight transmission mediums, allowing them to not only serve as static redirection artifacts, but as dynamic tools for enhancing human-computer interactions.